All right, so phase 2 project starting, and we are halfway through material, which is still crazy for me to think. So it also says 20 to 30 hours. I don't think it takes that long. It's really, for this project, you get what you put into it, in my opinion. With modeling, you'll see that, there's an infinite number of ways to do it, and you're never done with modeling. So that's also a question that I do want to address at the end. When are you done with your modeling? And I'll talk about that later on. So overview, what we're going to do is we're going to use regression modeling to analyze house sales in a northwestern county. So we have the King County house sales data set, and King County is the county that includes Seattle, if I'm not wrong, in Washington. And the data set is provided to you in this repo over here. And then you also have a description of the features that are included. So actually, let me just really quickly show you what it looks like. You have your data set in this data folder. And with this, they just give you like a quick description of what each column means, because I think some of them are not very clear. Like, for example, if you were to just see square foot living 15, you have no idea what that is. So something to remember also, if you are including feature names like this in your presentation, remember to explain what square foot living 15 is. All right, so what we're doing is we're building a regression on this data set. Up to you to decide what data you're going to use and how you use it. And I'll go into more detail when we go over the guidelines as well. Something really quickly that I wanted to talk about was, before I get into like the guidelines, the deliverables are exactly the same as before. You're going to submit your GitHub repository URL, your PDFs of your Jupyter notebook, and a non-technical presentation, as well as your blog post. So before I get into all that, because I know we have a few new students that didn't use this interface before, I will send out the video of submitting the projects, because I went through that last phase. But really, really quickly, how you submit it, I've moved all the milestones to the top. And actually, I have a student view that I can do here. So this is what it looks like for you. Things to submit. I know some people didn't do this last time, which is honestly, it's fine. But with your GitHub repository URL, when you click submit assignment, you just have to paste your URL. That'll be there. For your project, you're going to have to submit PDFs, and 3 PDFs you're going to need are a PDF of your README, PDFs of your notebook, and am I forgetting one more thing? Oh no, I think it's just those 2. Yeah, I think it's just those 2. And you can also submit a PDF of your presentation if you want. But that should be in your GitHub anyways. Finally, the blog post submission, same thing as the URL. You would just go into the blog post, submit your URL to your blog post there. Questions about submission really quickly. Again, I'll link the video where I walked through submission for the last project. I'll remember to put it in the guidelines later on. Okay, so I think rather than going through all of the details in this project overview, I think it'll be a little bit more efficient to just walk through the guidelines and what your project is going to look like. For your reference, I have linked also the rubric that I'm going to be using for this project. Let me know if you can't access this. I think everyone should be able to have access, but this is the rubric that you're going to be graded on. So good to take a look. I know a lot of people tend to go like way above and beyond this rubric, and they're like, I can't finish this project. But if you look at the rubric, you know what things you have to check off. Also, I've linked this resource that is making your GitHub repo. I'll also link that video, but don't forget to make your GitHub repo for your project, for your paired project. All right, so with this project, I know with the last project, I didn't really do this, but with this project, what something else I'm going to be focusing on is the structure of your notebook and how well your notebook is, documented and formatted. So this serves as a guideline of the sections that should be in your notebook. One more thing I want to clarify is everything doesn't have to be in one notebook. Again, similar to last time, feel free to split up your notebooks into a few, because if you have really long notebooks, it does take a while to run. So I will also mention like where are the places that I think would be good splits to make if you're curious. All right, to start, with this notebook, you want this notebook to be a standalone product. Hopefully someone who has technical knowledge of what you're doing will be able to read your notebook, not need any other resources, and fully comprehend your project. So that's the whole purpose of this notebook. So it's going to be a very, very comprehensive, pretty detailed documentation of your entire project. So to start, I highly recommend that you really start with a strong introduction or an abstract. And it's not so much about like talking about, you know, the context of King County and like what it's like over there, but start with why are you doing this project? And this is where you set up your business case or your business problem that you're trying to solve. They mention here that you have a business problem here. And they also say here, it's up to you to define the stakeholder and business problem appropriate to this data set. So for example, in the last cohort, what they did, some people were like, all right, I want to be a construction company and I'm going to use this model to decide like, what should I focus on when I'm building a house to generate the most profit? Other examples also include like, maybe I am a real estate investor. I can use this model to project prices and to see if like properties are over or undervalued. So it's up to you and your partner to come up with a business context that makes sense. That's going to be important because the conclusions that you're going to draw at the end of the project are going to link back to this business problem. And I'll talk about conclusions a little bit when we get there. So questions about like the setting up of context so far. I will say maybe just like one paragraph about like what you're hoping to learn or what you're hoping to do with this model. All right, so next step, it would be to finally start coding. You can import your data, clean your data, and do your EDA. Here I have some bullet points of what you could do. Perhaps ask some questions about your data. Do you have some hunches or some hypotheses on what your data looks like? Maybe you have a hunch that like, I know one particular feature or column that they have here is waterfront. So if your house is on a waterfront, is it significantly more expensive than houses that aren't? So this is also an opportunity to do hypothesis testing or like run a t-test. You don't have to, it's definitely not a must for this project, but if you wanna, you know, use that material that we learned at the start of the phase, this is a good opportunity to do that. In your EDA, you can also do your EDA to feed into your modeling. And what I mean by that, in your modeling and for linear regression modeling, we had talked about assumptions. For example, linearity assumption that your independent variables should be linearly related to your target variables. You can do that in your EDA, so you don't have to do that later on. And maybe as you're doing that, take note of what are the variables that are more or less linearly related to your target, and maybe that will help you make decisions in your modeling process. So here I have which features are correlated with your target. In your EDA, I think the most popular visualization that is done in this kind of project is just scatter plots, because through scatter plots you can learn a lot. You can see like which features you might want to transform. Scatter plots and histograms as well. And actually, let me just make a note of that. Lots of scatter plots and histograms. All right. So with your EDA, you can also take note of what features you might want to transform, what features are collinear, and here I have bonus statistical tests. So here you're just trying to explore your data as much as you can so that you go into your modeling process with as much information as possible. One thing that I think is going to be very important here is to interpret or take note of what you're seeing in your visualizations, right? Like, let's say you plot, you know, your scatter matrix with all of your variables and scatter plot against each other. With that, if you have that there and you're like, okay, yeah, this one looks correlated, this one doesn't, better to literally like write it down in a markdown cell, just so you have the information there for not just yourself, for you to refer back to later, but also for someone who's reading your notebook. When I'm going through your notebook, it'll be a lot easier for me to see as well what you're thinking of at that time. So yeah, that will be the EDA section. Questions at this point? All right. So this is the first place where I recommend having like a break. If you want to split into multiple notebooks, usually after your EDA is a good place to stop your notebook and start a new one. If you do your data cleaning there, you could export your cleaned CSV so that you can import that later when you start your next notebook. One point that I did want to circle back to is in the interpretation of your EDA and your graphs, it's very, very important to outline what you're thinking at the time. If you have any like thoughts going into like the next process, it's really important to document it, because I think something that I noticed over this last round of project reviews is that you guys all have really good ideas as you're going through your processes. But if you don't have your ideas written down on your notebook, someone like, for example, a hiring manager or a technical interviewer going through your notebook would not know that you have these thoughts unless you're there explaining it to them. So better to over-explain than under-explain so that nothing is discounted. All right, so after the EDA, the next thing that you're gonna do is your feature engineering. And I say this feature engineering part 1, because this would be the feature engineering that is not affected by your chain test split. So remember I talked about data leakage. You don't wanna like transform your variables as a whole, but you wanna transform your variables separately as a train set and a test set. So here would be like the very basic feature engineering. Perhaps you do your one-hot encoding and get dummies for your categorical variables. Here I say don't do any transformations that have to do with the distribution of your data before your chain test split. Perhaps you can also, at this point, I think it's okay to take out outliers if you want, especially if they're based on like certain thresholds, do that as well. So really, really simple feature engineering before you get into your chain test split. And then you do your chain test split. Questions so far? All right, so there is a little bit of flexibility for this next step. When do you do your baseline model? And so your baseline model is going to be the very first model that you run, and it's going to be what you compare your results to. Something that people like to see on resumes is the progress that you made over your modeling process. So for example, let's say with your baseline model, you start with like an R squared of 0.3, and then you work your way up to an R squared of 0.8, for example. That's like almost 200% increase in your R squared. And just having that number in your resume, people like to see that. And so there is a bit of flexibility of where you want to do your baseline model. You can definitely, make more changes since you already sort of have an idea of what changes you're going to make based on your EDA. You can definitely make those changes first and then run your baseline model, or, just start with like the worst data, get really, really poor starting metrics, and then build off of that, So it's kind of up to you what you want to do with that. I personally just like to use like a really bad baseline model so like my improvement is better. But that part's really up to you when you want to do the baseline model. So with your baseline model, things I like to keep track of, firstly, the R squared. Also RMSE, like your first model, how off are your predictions on average? So I like to do those in the baseline model. Also, if you want to consider, for example, if you're at your baseline model, let's say you're throwing in like all your categorical variables as well. Let's say you end up with like 100 columns, maybe how many of those are insignificant? That could also be something that you keep track of. Let me make a note of that. How many significant p-values? All right, so with the baseline model, this step 6 part is going to be the bulk of your project, iterative modeling. And this is the part that I'm actually really gonna look at, and this is the part that I'm going to be pretty much grading your entire project on. During this iterative modeling process, you're going to be running a lot of models. And I will say like at least 3 to 4 models. And I say 3 to 4 at least because some people like to make like many tiny little changes and end up running like 10 models. Some people like to wait till you have significant changes to your feature set, then run a model. So it's honestly up to you how often you want to run your model. But anytime there's some change, I would say you have to explain what changes you're making. Like for example, from your baseline model, you had like 30 insignificant features and you're dropping them. And that's, I would say, like document that and then run your next model. These are some examples of what you can do. You can remove your correlated features because you don't want multicollinearity, remove your high p-values, you can transform or scale. And again, remember with your transformation, you have to take note of what your training parameters are. And we're actually going to talk about this tomorrow, interactions and polynomials. Lots of things that you can do with your feature set. And yeah, just remember to explain what it is that you're doing at each step and also perhaps why. With each model, you're going to interpret your p-values and your r-squared values. Are they improving? Is there any like drastic changes in significance of your variables? Something else that you might want to look at is also your coefficients. Let's see, coefficients. Oh, nice, autocomplete. Coefficients, are there any unexpected coefficients? So do coefficients make sense? Like for example, we're doing housing prices, and one of the features is, I think, number of bathrooms. And you would expect that, you know, if you have more bathrooms in your house, your price will go up. So if you see a negative coefficient for bathrooms, something seems to be off. Maybe you want to do additional EDA to just like check out that pattern. Maybe you have just like weird data by itself. Or, you know, there could be something wrong in your model. Maybe you have bathrooms being collinear with something, that's why it's bringing it to a coefficient that you don't expect. So definitely you want to take a quick look at that. I would say for this iterative modeling step, you don't have to go super in detail and like look at every single coefficient, but good idea to at least look at some of them. I think for the most part, just like positive and negative, just because you should have an idea of, you know, which features would positively or negatively affect your price. So at a couple intermediate points, some people like to actually do this at every point, but I don't think that's super necessary. Check for your assumptions. Look at your QQ plot and look at your residual plot, just to see like, are they fulfilling the assumptions? Here I've actually linked a link that has all of the different interpretations of your QQ plot. Basically, if anyone remembers, a QQ plot looks like this. And if it is normally distributed, if your residuals are normally distributed, they should be hugging the line. They shouldn't be off by here. And then basically, I honestly never remember the interpretation of the QQ plot. So if I see something like this, I will look here and be like, all right, which one does mine look like? I think something like this. And then just write out that interpretation. Other than that, where was I? Other than the QQ plot, the other thing to look for is the residual plot. And so the residual plot basically plots your residuals against your predicted variable. So here you can see that I have, and this is the miles per gallon car data set. So here I have all the different miles per gallon, and these are the actual values, and these are how off the predictions are. So with this residual plot, you can learn quite a few things. One, you can check for your homoscedasticity, that your variance across the entire range of your target variable is what am I trying to say? It's an equal variance throughout. Basically, the idea is you want your values to sort of like be able to be hugged between two horizontal lines. What else you can learn from here is where are you losing predictive power? So here you can see that in this model, and these are the miles per gallon values on the x-axis, you can see that sort of between like 10 and 35 is actually predicting pretty well, just like a plus minus 5. I don't know what that means in context of cars, but between 10 and 35, it's pretty constant. The errors are pretty constant. But past 35, I lose predictive power. I end up under predicting miles per gallon at these higher levels. So that's something else that you can learn from your residual plot, and maybe it's something that you take note of. Maybe you want to like limit your model to only predicting between like a certain range. You can definitely consider things like that. Questions about these plots so far? I know I didn't go very in depth for these plots the last study group, but essentially this one is really just a scatter plot of your, you can see these are my miles, this is my miles per gallon against like what I'm predicting minus miles per gallon. And this QQ plot, it comes from stats models. And I've also linked the interpretations for that. All right. Something else that you can do at intermediate points is just test with your test set to check for overfitting. And I'll walk through, I think I didn't do it super in depth earlier, but I'll walk through that in a little bit. Test with your test set to check for overfitting. Just look at the RMSE between your Y hat train and test and your actual Y train and test, just to make sure that no overfitting is occurring. And then here it says that perhaps write a function that only selects features that you ended up using and does the scaling. And I'll talk about this, actually I'll talk about this later on within the final model. Things to take note of, if you called features, meaning if you dropped any variables, make sure you do the same for your test set, because when you're using the .predict function later on, the number of inputs have to match the number of features that you trained your model with, and the order of your features does matter. And then you can scale your test set based on your train set parameters. I mean, that's what you should do. And then finally, I have here run cross-validation. And cross-validation is something that we're going to talk about tomorrow more in depth, but I'll go over really quick when to do this cross-validation and like what it's used for. Questions so far? After this, I'm going to talk a little bit about, I'm going to talk about cross-validation first, and then later on with this prediction function, I'll talk about making predictions.
One way of updating your test set, would that just be like creating another test train, like redoing that code, and then just using a seed to keep it like the same data set?
That's a good question. Typically, you wouldn't recreate your train test split. It will be more clear why next phase. But typically you don't redo your train test split. You do your train test split before you even start the modeling process, such that you make sure you're using the same train and test split throughout. So that's actually, it makes sense because procedurally you'll end up with the same result as long as you remember that, like, you know, the parameters that you're scaling with are only from the train set. So what you might have to do that will be a little bit like, I think a more roundabout way would be like, you would first get like the mean and standard, let's say you want to normalize, you're gonna get mean and standard deviation of your train set, put your data frames together, scale, and then resplit with the same train test split. That will give you the exact same result, but I think because of that process of like rescaling, it'll be different. Typically what people do at this stage is you just take note of what the mean and standard deviation are, and then just scale the two separately. I forget if there's another part of your question.
No, that was it. Thank you.
Okay, you're welcome. All right, so quickly into cross-validation. Let me see if I actually have that notebook that I'm going to go through tomorrow, and I can pull it up real quick. I do have it. Okay, this I believe is already up on the study group repo, but cross-validation is basically to make sure that your model isn't overfitting or overtraining to a specific subset of your data. So cross-validation is done after you've trained a model, and just running cross-validation makes sure that, you know, your errors across different splits of your model are somewhat constant. Let me see if I can make sense of this as we run this. Why is this happening? Let's see. There we go. Give me a sec, guys. Let me just take the data file out. There we go. All right, so we're also prepped for tomorrow. There we go. So this is just a model that I've trained. Doesn't really matter at this point. And here's where I do cross-validation. And you can sort of see, oh, this is the hard-coded version. So cross-validation here, what we're doing is we're actually feeding it in the trained model, the model that we've already trained. And here we're feeding it like some X and some Y. And cross-validation equals 10 basically means how many different subsets are we going to use in our data. I'll get more into this tomorrow, but this is basically running your model on 10 different subsets of your data and taking a look at the error. So here you can see we have errors that range sort of between like -5 and -28. I don't know why they do negative mean squared error as the scoring here. This is the scoring that is built in here. But yeah, basically you would just have to unnegative this and then take the square root, and that's your overall error. And what you're looking out for here with cross-validation is you're just trying to make sure that your errors, there's no like one subset that your error is like really, really off. Like possibly here, this -28 is very different from the rest of it. So one thing you could do is also just look into that subset and see what's going on there. Maybe you have outliers in that subset. But cross-validation is something to just make sure that your model works well across different splits of your data. And this linear regression model here has already been trained. Here's something to remember as well. And usually this would be your X train and this would be your Y train. So you actually do cross-validation on your train set and then finally with your tests. And then finally you just test overall with your test set. I think I'll go way more into detail with this tomorrow, but yeah. Questions about that? Okay, so back to this. When you're done with your cross-validation at like several intermediate points in your modeling process, basically with this iterative modeling process, you're gonna run like at least 3 to 4 models. I will say at least 4 because you're working in pairs, at least 4 models, and interpret all these different things. After you're running all your models, decide on what your final model is. Different people choose their final model on different metrics. So you can choose maybe the one that has the best R-squared if that's what you want to do based on your context, your business context. Or maybe you want to just get the one that has the lowest RMSE or ones with the coefficients that make the most sense. Up to you to decide. As long as you can explain why you're choosing that model over other models, you're fine. With your final model, this is where you have to do all of the interpretation. So interpret your R-squared, interpret not all, but some of your coefficients, at least like the main ones. If you're a construction company, maybe you want to make sure that you have like, I know one of the features is talking about like the grade of your building materials, and maybe that's something that you want to highlight for a construction company. Look at your RMSE and check your assumption graphs because it is your final model. So with your final model, just have a little bit more detailed of an interpretation. Finally, this is a bonus. Create your prediction function. I'm going to talk about that in a little bit. And with that, you can basically what you're going to do here, you're going to create an array of inputs that match the feature set that your final model was trained on. I did talk about this super briefly on Tuesday, but I'm going to go through it again really quick. So in this example, let's see what the final model I have here is. All right, so my final model uses these features. So I think it's easier to do this using the scikit-learn package. So if you did a lot of your iterative modeling process using the stats models one, I usually like to just take the same subset of features and run it through scikit-learn. Scikit-learn just, I feel like, has a more streamlined way of making predictions. So with the predictions, let's see, everything is, all right, so these are all like training the model. No, not training. This is doing your train test split. Are there two different? Oh, I was explaining this, yes, on Tuesday, I forget. So here you have your train test split, and here you are instantiating your model, fitting your model, and then getting these predictions. So with the RMSE, with the RMSE, what we're doing is we're comparing these with the actual Y values just to see how off your predictions are. And that I talked about on Tuesday. So let's say you want to make predictions for completely unknown data. How you do it is you actually do have to take note of what are the features that you're putting into your train set. So something I like to do is just take a look at what my X train looks like. All right, so X train here takes in 4 variables in this order. So basically what you have to do to make a prediction on unseen data. So let's say I want to assume I have a car that has like 0.5 acceleration, 0.1 weight, and these are scaled, which is why it's those numbers, and origin of 2 instead of 3. Basically, it has to have an array of this shape, and I feed that into the predict function. If you notice, this predict function is the same one I used to create my y hats. So it just needs to be an array. And this reshape thing, I believe, is because this is a one-dimensional array and this function takes in 2 dimensions. So I believe when I do this, it's the same as well. There we go. And so with that, you just have to feed an array that has the right shape, which is basically the right number of columns. Make sure that the columns match, the training columns. And then once you feed it into the .predict function, it'll give you this value of your prediction. What I mean by creating a predict function is what you can do is define a function that, for example, I'm not going to code it out completely, but I'm going to pseudocode it. Let's say I want to predict miles per gallon. And then I want to take in several inputs. The inputs, it's really up to you. Maybe you want to take acceleration, weight, and then maybe origin. And then what I'm going to do is, because I know that these are scaled variables, what I would have to do is scaled acceleration, do all of that scaling onto my acceleration, because likely you're going to be given like the actual acceleration numbers, not the scaled ones. So scale your acceleration, scale your weight. And for something like dummy variables, I would assume for origin, you can have it taken like, I don't know, 1, 2, or 3. So for your origin, maybe you want to say, if it's, maybe you want to write something like an if statement. So if origin equals to 1, you would have like, let's see, maybe your output can be like a list of like 0, 0. And then if your origin is 2, output a list of 1, 0, because you need this to correspond to this. And then basically, after you're done dealing with all of that, you have to create this array. So what I would do is maybe do something like numpy.array. And I believe because these last few are lists, I can do like scaled acceleration, scaled weight. And then maybe I can do like I think this works. If I do plus out, my output for whatever origin, that will actually create the array automatically. Let's see, raw data, or more like input data. Do that, and then get your prediction to be linreg.predict. So you can actually call your model in there, and then linreg.predict on your input data, and then you can return your prediction. So that's kind of what I mean by creating your prediction function. This part is going to be a little bit annoying to deal with. Only in the next phase we'll talk about methods to make this a little bit easier. Or, Google it if you're curious. But yeah, this part's going to be a little bit irritating to figure out, but it's fine. I will say like this prediction function part is optional and a bonus. Questions on this? Cool, awesome. So in the same notebook or in different notebooks, oh, something I forgot to mention, if you want to have like an additional split in notebooks after you're doing your iterative modeling, I usually like to have like my final model in a separate notebook so it's cleaner, where I can like interpret everything properly, have my prediction function there, and then following that, have your recommendations and future work. So with this, recommendations, they have to lead back to your why, which is why I say the context is very important. I think a data scientist's job is to be able to do all this science stuff and then explain it to non-technical stakeholders. And so that part's going to be very important. So don't forget to connect your recommendations back to your why. And then also, like, what have we learned from this model? Was there anything interesting about like your coefficients, or about maybe something through your EDA that you learned that was interesting? Just like a good summary there. Finally, this part is also optional. An appendix or an archive section. You could put this in a different notebook if you'd like, but basically this section with past experience of other students, you end up running way more models than you present. And so just, to like not delete models that didn't really work out, maybe just keep them in like a separate notebook or at the bottom of a notebook to represent your like archives or your appendix, or basically models that you tried, but like things didn't really work out well. Maybe you're trying like a really, really minor change that you don't think is very significant to talk about. You can throw that there. So that's pretty much the entire process of the project. After talking about it, it seems like it's a lot, but y'all will be okay. Really quickly, because I don't really have, I'm not the one conducting your office hours for this project. I have linked a student example of a presentation, as well as the template, very similar to what I was talking about previously for the last project. The main difference for this project presentation and the last presentation is the line to toe of like how technical or non-technical is going to be a little bit harder for this. Because here, you know, we're going to talk about same thing, introduce your data, talk about some of your EDA, some of your modeling. With your modeling, what I really want to see is the process of your iterative modeling. Like for me, the most effective ones are literally listing the steps of the things that you did, maybe like drop high p-values, remove collinear features, log transform all continuous variables, things like that. I think if you have a slide that says that, it'll be very, very clear for me what you did. And then here you would just have to evaluate and interpret your model. Something that you remember is that it is still a non-technical presentation. What I really want to see is if you say things like R squared or p-value, say why that's necessary, right? Like if you're saying hi R squared, imagine your audience doesn't know what an R squared is. Just quickly say that, all right, this R squared of 0.9 says that we're explaining 90% of our independent variable, of our dependent variable. Or just say that, you know, our model fits the data at a rate of about 90%, something like that. If you're saying p-value, say that, all right, why do I want a low p-value? Just quickly say that, well, low p-values just mean that your features are significant in this model. So don't just say these like technical terms without explanation. I would say just like a one line, just so it's not a completely foreign concept to an audience. But yeah, the rest of the presentation is going to be quite similar to the last one. Just that iterative modeling part is going to be different, where previously you just had like different EDA and different recommendations. Questions about this? All right, I do have a student example if you want to refer to that. It is done on a different data set, so it will be interesting to see. But yeah, it's done on a data set predicting, I think, maternal mortality. Yeah, maternal mortality rate. So a little bit grim, but structure of the presentation is there. Let's see, what else? I will put a bunch of other resources through questions that I've gotten this week. I've collected a bunch of resources and I'll just put them down here. I have a suggested timeline here. And one thing I want to say with this timeline, because we have our cohort break that is basically the week after the project week, I think it's fine. And I did double check that it's fine if you have a late submission, fine if you keep working on your project for the break week. Of course, pros and cons. If you finish it before that break week, you get it over and done with. But also you'll have more time if you really need to. And it's up to you whether you want to like really have that break or not. So what I'm saying is I won't check your submissions until the end of the second week anyways. So as long as you have your project submitted by then, I don't care if you take 1 week or 2 weeks to finish it. And then we'll be presenting our projects on the Monday after Thanksgiving. Questions about that? All right, well, one other thing, you can see here that this is space for questions, and I believe the sharing settings are such that, yeah, any one of you can actually edit and ask questions. So all of the instructors that will be covering for me while I'm out will be using this guideline doc to basically track questions and help with office hours. So if you have any questions, you can leave them here. Oh, I just saw a question saying like blog post too. Yeah, blog posts you can also submit just before end of Thanksgiving break. So yeah, any questions that you have for anybody that's covering office hours, leave them here. All of them have the link to this doc, so they'll be referring to this with office hours. While I'm out, and let me see if I have the homeroom. Oops. With the homeroom, I have your project pairs listed here now, but this is basically what next week is going to look like. Talked about the section for questions that you can all add to. And if you do have random questions popping up, I noticed like y'all haven't really been using this much, but that's fine. If you are on Slack and you tag @DS Support Squad, it actually notifies all of the data science instructors, and they'll see your question, and they're actually all in our Slack channel too. So they will see your question and help answer. And they know that I'm out as well. So I think we'll have a bit of priority there. Here I basically have all of the instructors that will be covering the different office hours. Amber will be actually doing a recap of web scraping. Oh, and something I completely forgot to mention is with your data, you actually have an option of adding your own data to this if you want to include additional features, which can happen either here or during your iterative modeling process. So I'm going to add additional data / features. So basically, some examples of this, some people use like census data on like the county and included that in the as one of their features in their regression model. It's completely optional. You definitely don't have to do this, but I know like about half of you all did like APIs or web scraping for the last project. So if you want to keep doing that, you can definitely do that for this project as well. It does make your project a little bit more unique, but it's not something that you will not pass the project for if you don't do. So because there is that option, because there's that option, Amber will be going over a recap of web scraping for this project as well. Questions on that? All right, let me see if I'm forgetting anything else. Yeah, again, I won't mind as long as you submit your project before the 29th, and then y'all will be good. Let's see. I can't think of anything else that I haven't mentioned. Does anyone have any questions?
Hey, Ish, it's Chrissy. I have a question.
Mm-hmm.
So I really struggle with GitHub and pushing files and pulling them down. Is there like a flow, like best practices that I can refer to?
I have this. This one is basically how you set up your GitHub. I do have instructions here. So if you're working on branches, this is how you would push your material. And if you're putting your work together, I have all of these here. Let me see if I have, let's see, here. If you are working off the master branch, you would do your git add commit and push, and then pull if you have changes. Let me see. Things that you could potentially run into with Git is, especially if you decide to work off the master branch, both of you, if both partners decide to work off the master branch, extremely important to be communicating, because if you're trying to both push different changes up to a repo, you end up with a lot of conflicts. So highly recommend, I think for like easier, for less trouble with Git during the project process, better to work off separate branches. And I have like all the instructions for like creating branches, and you can do that 2 different ways, exactly the same result. With branches, you don't have to worry about your work conflicting with your partner's work. And then if you have like GitHub issues, I think with GitHub, if you have issues like merging your branches, we can definitely talk about that during like project review. That's not something that I'm going to be grading your project on. Git, I will say there are students that like even by capstone, like Git is still like super foreign. Definitely took me like a good year before I felt comfortable with Git as well. But yeah.
Okay.
Yeah, it's definitely not easy, and I do recognize that for sure. But yeah, I've linked this one here. Just so you all remember how to set up your own repos, and I have like just a few lines of like how to collaborate on Git. Let me see if, yeah. There are a couple things that I will add to this as resources. So definitely, I think it's a good idea to keep this open. One, because I'll be adding resources today and tomorrow, but two, also good for questions. I would say these questions are more for like less time sensitive questions because these will only be addressed during the office hours. But if you do have questions, tag the DS support squad. Cool. Well, I can't think of anything else that I'm missing. If there is anything, I will do it tomorrow during our topic 20 study group. So not to worry. Yeah, any final questions?
I have a quick question on the, I think it was the baseline step.
Mm-hmm.
Is that, it's not clear to me if in that baseline test there, are you testing the train and the test? Or is it before that? You're doing something else at this stage?
So at this stage, your train test split has already been done. And then you're going to run your baseline model with like, you haven't tuned your features or anything. So you're running your baseline model on you're training your baseline model using your train set. And then something that you can also do is test with your test set. So basically at this step, and again, I like to do this with scikit-learn, but you can also do it with stats models. I think I have it, not here, but I think I have it in section 18. So let me quickly pull up our notes from section 18. That is not this phase. So I hope I have the cells run here. But basically, yeah, you can find the RMSE for your train and test set for your baseline model. And that's also something that's good to compare, your future models to. Hopefully this will run. If not, I can also open it up separately. Give me a second to get this open.
But if I'm understanding it, it is a test of, like you're looking at the RMSE of train versus test.
That's right. You are looking at the RMSE of train versus test.
Before you do any training, really.
Before,
right?
Yes, kind of, yeah. So
yeah.
Let me see if I have that here. I think I have it here. So this is using stats models. And unfortunately, I know I cannot run these cells because it will lead to conflicts if you guys pull down this repo, because I'm opening this from your repo. But yeah, you can see that this is the train test split for stats models. I basically gave it the data frame and I'm doing the train test split there. Once I've trained the model, you can actually run the dot predict on your test set. And then with that, you can get your y hat and your y test, and then basically compare your squared error like that. You can actually also get a RMSE for your train set in the same way. You can do like model.predict train, and then compare that to your y train. Good to have both error metrics, just to have an extra metric to look at. But yes, okay. You are looking at both your train and your test root mean squared errors. One thing that would be interesting, definitely like a super level up if you're very comfortable with Python, because you'll be ending up running a lot of the same code over and over again. Like with every single model, you're running like, the formula, this model.summary steps, because you're going to be doing that over and over again. If you feel like you're up to it, you can actually write functions that will do all of these steps for you. So for example, you can actually define a function to maybe pick out which columns you want to run. Run that, maybe at the same time output your RMSE, your MSE, your maybe even like your QQ plots. This is definitely a level up. But if you are one of those people that you really enjoy coding in Python, that might be something that you consider doing as well. I don't know if anyone needs more clarification on what I mean by that. Cool. Yeah. If you like define a function, you can literally like define a function and within that store like your formula, your model, and like output whatever it is you want to output. All right, so I think that's all I have. If I do remember anything else, I will address it tomorrow. But if there are no final questions, going once, going twice. All right, I will see you all tomorrow then. Have a good rest of your day, and I'll see you all at one-on-ones or yeah, just tomorrow. Bye, everybody.
All right, thank you.
You're welcome.